So you have gotten Kubernetes clusters up and running, maybe in a data center, maybe at the edge. And on these clusters, you're running critical stateful applications, databases, messaging queues, monitoring tools, all of which rely on persistent storage. But what happens when a disaster strikes? Hardware failure, power outages, site level issues, you name it. You want your data protected and you want your workloads to fail over to a secondary cluster. That's where Nutanix Data Services for Kubernetes, or NDK, comes in. I am Nimal with the Nutanix Technical Marketing Engineering team, and welcome to another video on Nutanix University. NDK is a native BCDR solution purpose-built for Kubernetes. It is tightly integrated into the Nutanix Kubernetes Platform and available as a platform app. And it is included with NKP Pro and Ultimate licenses. But the value doesn't stop there. NDK can also be deployed as a standalone solution, giving you the flexibility to protect your stateful applications on other distributions, including OpenShift. NDK captures your entire application, which is part of your pod or deployment, the related resources like secrets and config maps, and the associated persistent data. All of this is a single cohesive unit. This packaged approach makes it easy to snapshot, replicate, and restore your application and its state to another site with minimal effort. With NDK, platform teams can empower developers and Kubernetes users with a self-service experience for managing storage and protecting their data, without needing to become DR experts. Alright, now let's see how it works. Meet John Wick, a developer who loves the Nutanix Kubernetes platform. He logs into NKP and is a member of a specific workspace, which grants him access to only the clusters within that workspace. In this case, there are three clusters, a primary cluster named DCHQ and two DR clusters located in New York and San Francisco. Now, John has already deployed his RobotShop application to the primary cluster. And to check on it, he opens the built-in Kubernetes dashboard available within NKP. Now, the app is running in the RobotShop namespace, and as you can see, all the microservices are up and healthy. Now, this is a stateful application, and we can tell because there are two stateful sets with associated persistent volume claims for MongoDB and Redis. The underlying storage is powered by the Nutanix CSI driver, which comes pre-installed and consumes Nutanix Unified Storage. The app is exposed via a load balancer service. So John opens the external IP in a browser, and there it is. The RobotShop app is live. He logs in and he can view his previous orders. Now, this is data that is stored inside that MongoDB database we just saw. Great. Now let's protect this app with NDK. NDK introduces a set of Kubernetes native custom resources that make disaster recovery seamless. The platform team has already set up a couple of important objects, such as a remote resource and a replication target resource. These define the target cluster and the target namespace the application should be replicated to. The status of these targets can be confirmed to be healthy and ready. John only needs to define an application custom resource that represents the RobotShop app. This object captures everything in the namespace: pods, deployments, secrets, config maps, PVCs, you name it. And if needed, he can exclude certain non-essential objects like Cilium endpoint from protection. With the application object in place, he then creates an application snapshot. This snapshot references the application and captures both the Kubernetes resources and the persistent data from MongoDB and Redis. This gives him a point-in-time snapshot ready to be replicated and restored to any of the other two DR clusters when needed. Now, if you're running Kubernetes at scale in an enterprise environment, manual snapshots are not enough. You will want automated protection using schedules and policies that align with your business SLOs. So let's take a look at a common architecture using three NKP clusters. You have the primary cluster that runs in the main data center in DC, a second cluster in New York for near real-time DR, and a third cluster is in San Francisco for long-term retention. Now, in the setup, NDK lets you define multiple replication schedules: an hourly replication to New York giving you a 60-minute RPO, and a daily replication to San Francisco offering a 24-hour RPO. This way you can tailor your disaster recovery strategy to meet different business continuity needs. and to see how to configure these policies and schedules using NDK's Kubernetes native resources. Stay tuned for the next video in the series. If you found this helpful, don't forget to like, subscribe, and hit the bell icon so you don't miss any future videos. And if you'd like to get hands-on with NKP, NDK, or any of your products, check out our free test drive available at the Nutanix website.